Hi there, in this video I'm going to do a revision question on numerical methods. So let's take a look at this question. So y is given as the square root of 5 to the power of x plus 2, and in part A, complete the table below, giving the values of y to 3 decimal places. So let's go back to the paper and pen. So we're given y is the square root of 5 to the power of x plus 2, and we need to work out the values of y to complete the table. So if we go back to the screenshots, the first blank that we need to fill in is the y value for when x equals 0. Back to the paper and pen. So when x is equal to 0, y is going to be the square root, so it's the square root of 5 to the power x, which is 0, plus 2. So if we calculate this, and the question did say to calculate to 3 decimal places, you should have 1.732. Back to the screenshots. Now we have another blank to fill in. We need to fill in the y value corresponding to 0.5 for x. Back to the paper and pen. So when x is equal to 0.5, y is going to be the square root of 5 to the power of 0.5 for x plus 2. And if we calculate that, and to 3 decimal places, if we calculate that, you should have 2.058. So back to the screenshots, another blank to fill in. So we need to fill in the value of y corresponding to x is equal to 2. Back to the paper and pen. So when x is equal to 2, y will then be the square root of 5 to the power x, which is 2, plus 2. And if we make that calculation, if you plug that into the calculator, you should have an answer to 3 decimal places, 5.196. So these are the solutions that completes the table for y. So back to the screenshots. So in part B is to use the trapezium rule with all the values of y from the table to find an approximation for the value of this integral, and it's a definite integral between limits 0 and 2 of the root of 5 to the power of x plus 2. So let's think about this one. Let's go back to the paper and pen. So here is the integral, and we need to apply the trapezium rule to solve this integral. Now, let me give you the trapezium rule. So in order to work out an integral I using the trapezium rule, here's the formula. It's h is the width, so it's the width of the trapezium, and the width must be constant for this rule to work. So it's the width divided by 2, multiplied by the first y ordinate, so it's the first y ordinate plus the last y ordinate, so it's the first and the last y ordinate summed, plus 2 times the sum of the remaining, so sum of the remaining y ordinates excluding first and last. So sum of the remaining y values or y ordinates excluding first and last. So let's go back to the table. Now the width of the trapezium, as I said, the width has to be constant. Now the width comes from the separation of consecutive x values. So if we look at the table, from x equals 0 to x equals 0.5, the separation is 0.5. The separation between x equals 0.5 and x equals 1 is still 0.5. Same with the separation from x equals 1 to x equals 1.5. Separation is still 0.5. And the same applies to the separation between 1.5 and 2. The width is 0.5. So it applies to a constant width. So the widths are constants. So we're all well and good. So back to the paper and pen. H 0.5, the width of the trapezium. And let's apply this formula to work out this integral. So in this case, the integral, or let me just complete it in its entirety. So here's our integral between limits 0 and 2 of the root of 5 to the power of x plus 2 with respect to x. So that is equal to, according to the formula, h, the width, is 0.5. So it's a 0.5 divided by 2 multiplied by. Now if we go back to the table, the first y value is 1.732. So back to the paper and pen, 1.732 plus the last y value, so back to the screenshot, 5.196, back to the paper and pen, so 5.196 plus 2 times the sum of the remaining y values, excluding the first and the last. So back to the screenshot, so remaining y values means 2.058, back to the paper and pen, so 2 times 2.058 plus, back to the screenshot, the next one, 2.646, back to the paper and pen, 2.646 plus, back to the screenshot, the next one, 3.630, back to the paper and pen, 3.630, close brackets. So here are the values inputted from the table, and if we calculate this, so when we calculate this, you should get an answer of 5.899. So it's 5.899. So 5.899 is the approximate solution to this integral. So that completes part B, and that also ends this video. So I hope you found this video helpful. If you're unaware of the trapezium rule, I have created videos on the trapezium rule along with additional examples, and I'll provide links to those videos in the description below. Other than that, I hope you enjoyed the video. A like rating is very much appreciated if you found this video enjoyable or helpful, and I hope to see you again. Thank you.